So if you give me a mathematical proof or a claimed proof of a mathematical statement, we have the laws of logic and the laws of mathematics. We can check whether the argument is correct or not. And now you can do that by computer. We have these formal proof assistant languages that do that automatically. And this keeps the AI honest in a way that it's harder to do in any other discipline. So mathematics has the best shot at filtering out all the bad use cases of AI and keeping the good ones. It's not perfect. Not every aspect of mathematics can be formally verified. Proofs are an important part of mathematics, but there are other things. For example, if you want to try to propose new conjectures or explain things in a clear way, there are many math tasks that AI may not be good at yet, but at least for some of what we do, there's a lot of potential.
Yeah, I can definitely see that. And one thing you mentioned was programs to verify the work of AI, correct? And as programs like that emerge and develop, do you think there will be a point where we can have a program robust enough to where we can have AI continuously generate ideas and have them be verified to create something new rather than be limited to what we already have planned out?
Yeah, that is the hope. So currently, if you ask an AI to generate ideas, it will generate all kinds of random things, and maybe a small percentage of them are actually interesting. But we can't verify an idea yet. But we may be able to borrow some tricks from the physical sciences. So, if a physicist or chemist comes up with a hypothesis, they can run experiments and try to gather evidence for the hypothesis. Not exactly a proof or disproof, but there are ways to become more convinced or less convinced that a hypothesis is true. I do see mathematics acquiring much more of an experimental side to it than we have currently. So currently, math is almost entirely theoretical. But with AI, AI could propose hypotheses, and then maybe it could also propose experiments to test these hypotheses. You may propose that some formula is true for all natural numbers. You test a few numerical ones. You find other special cases. You check whether it's compatible with some other facts in the literature. And this type of use case is still in its infancy. Again, because we don't have the ability to verify yet whether these things work or not, progress is much more holding. But as our expertise with using AI properly matures, I can see that happening. But still, maybe that's 10 years away.
Yeah, honestly, much better than I was thinking. 10 years sounds far, but honestly, in terms of research, that's not too bad.
The pace has been faster than I expected. I mean, there are people who had really sky-high expectations.
Yeah.
They thought by now mathematicians would be obsolete or science would be obsolete. But it is, already we can, AIs can already prove theorems that hadn't been proven before, usually by standard techniques. And it can discern some patterns that we didn't see before. It is still very unreliable, but the potential is there. We need to research how to use it properly and how not to.
Yeah, and I think something AI excels in is really structured repetition, something that has very strict instructions to do, and something it can repeat. And I mean, the point of it is to save us time so we can work on something that's more difficult for it, something that's more creative.
Right, yeah. They are different from humans, and it's a slight shame that somehow the current marketing of AI is I mean, even the name artificial intelligence sounds like it isn't a replacement for a human being, but humans do not like to do these very repetitive tasks. Like in math, maybe they will solve the first or second. If you give them a set of 1,000 problems, maybe they'll do the first one or two. But then it's great to then just hand off to the AI and say, you do the other 998. And so, this is, I think, again, maybe in 10 years it will change, but in the near term, the division of labor that's most natural is that, the human starts a mathematical project. So here are the first few steps, here's what I think should happen, and then the AI takes that sketch and fleshes it out, does all the grunt work, and it could massively accelerate existing workflows.
Yeah, I mean, it's at the end of the day, it's a tool, right? And it's there to help us simplify a lot of processes. But I think another thing about AI is that what do you think we could do about when it comes up with seemingly random explanations, right? Because what a lot of AI does is it comes up with plausible answers or something that seems like it could be right. But realistically, a lot of it is nonsense.
Right.
How do you think we can improve on that?
Right. So, in mathematics, the best thing we have found so far to deal with that is formal verification. So the AI can first come up with a natural language argument, which could be correct, could not be correct, but then we will ask either the same AI or different AI to convert that into a formal language. Every single claim that has to be converted into this precise language, which will verified by a very strict compiler, which is not an AI. It is a traditional, reliable piece of software. It is designed specifically to be extremely reliable. We've never found a major bug in the compilers of the major criticism languages. So if it passes that test, if it doesn't pass that test, we ask the AI to try again. If it does pass the test, then we have this big, long AI-generated formal proof, which may not be so easily readable, but actually you can then go in reverse. You can ask another AI to explain it. But also, the nice thing about these formal proofs is that every single